So we classified matter by its physical state. We can also classify it according to its composition. So we can divide matter into pure substances and mixtures. In a pure substance, there is only one type of atom or molecule. So if we look at the particles, we saw in the aluminum can the smallest particles were atoms of aluminum. When we looked at the mislabeled isopropyl alcohol, the smallest particles were molecules. So in a pure substance, whether you have atoms or molecules, they're going to be the same. If we look at this water here, water in a water fountain, and when we make these little space-filling models of water, they look like little Mickey Mouse heads to me. Little red and white Mickey Mouse heads. Each of them is the same. That's a pure substance. In a mixture, we have two or more different kinds of particles. We could have two different kinds of atoms. We could have atoms in a certain molecule. We could have 2 or 3 or 4 or 5 zillion different kinds of molecules. It's a mixture. And the thing about a mixture is we've got variable proportions. If you think about mixing, say, sand and salt, you could have a little bit of sand or you could have a lot of sand. How much of each can change? There's a table coming up here, I believe. Let's look at this real quick. I should move this to the beginning. So here's all of matter. We can divide it into pure substances and mixtures. And then we're going to see that pure substances can be divided into elements and compounds, and mixtures can be divided into homogeneous mixtures and heterogeneous mixtures. So this is kind of the big picture of what we're going to talk about. I'm going to go back. So one type of pure substance is an element. An element cannot be broken down into simpler substances. No chemical transformation can decompose an element into simpler substances. Now, when we say chemical transformation, we're talking ordinary chemical reactions. We are excluding nuclear reactions. Okay? It is possible to change one element into something else, but it requires a nuclear reaction, and those don't just happen all the time. And it's nothing we could do in this room, for sure. So we're qualifying that. So all the known elements are listed in the periodic table. There's one on the inside front cover of your book. And then on the back cover, there's an alphabetical order. And so one may be more useful than the other at different times. We also have a periodic table up here, and that shows all the elements. And we're going to learn a lot more about the periodic table as we go through the semester. A compound is also a pure substance, but a compound is composed of atoms bonded together as molecules for the most part. So water has hydrogen and oxygen atoms as molecules, but it's a pure substance because all of the particles are the same. So we've got 2 or more elements, but they are in fixed, definite proportions. That's different than a mixture where the proportions can vary. In a compound, the proportion's always the same. If you take water from the Nile River and water from the King's River and water from the toilet in the men's bathroom and you purify the water, it's all going to be exactly the same. 2 hydrogen atoms, 1 oxygen atom, every particle the same, because it's a compound. Mixtures are not the same that way. Compounds are more common than pure elements, and they can be decomposed into simpler substances. You can decompose water into oxygen and hydrogen gases with a 9-volt battery. And that's something you could try at home if you want. Take a glass of water and drop a good 9-volt battery in there, and you should see bubbles forming at each of the terminals. One of them is giving off hydrogen gas, and one of them is giving off oxygen gas. Should probably do that in a well-ventilated area because those gases are flammable, but it's not going to make very much. but you can decompose them. You can take a compound apart. It's like a compound is like a structure built with Lego blocks. The molecule is like a little structure built with Lego blocks. And yes, they stick together, but you can take them apart. A mixture is a mixture. It's just two different things or more, just mixed together, but not combined. So they're not chemically united, they're simply mixed together. It can be separated. The proportions can vary. A mixture can be separated through a physical separation. Like if you have spaghetti and water, because you boiled the water and you put the spaghetti in it and you cooked it. You have spaghetti and you have water, it's a mixture and you can separate it. You just pour it through a colander, the water goes through, the spaghetti doesn't. You have separated. You can cook the spaghetti with a little bit of water, or you can use way too much water. It's a mixture. The proportions do not matter. So here we have an example of some mixtures. Air is a mixture. We've got oxygen molecules and nitrogen molecules and other things floating around. And it can have more or less oxygen or nitrogen. There could be a bad smell in the air because of another compound in the air. It's a mixture. In the seawater, we have water molecules, of course, but we also have salt ions. And how much salt is in there can vary. If you go to the delta, you have fresh water coming in, and as it runs into the ocean, there's an area that's kind of, I think they call it brackish. It's kind of salty. It's not salty enough for ocean fish to be happy in, but it's too salty for freshwater fish to be happy in. And there's another, whole group of organisms that likes to live in that kind of medium salty water. But the salt in the water is a mixture. It's not a compound. Compounds have fixed proportions. So under mixtures, we can separate those into two categories based on how uniformly they mix. A homogeneous, we use a lot of prefixes and suffixes in science. So homogeneous, homo is a prefix meaning the same. It has the same composition throughout. It's uniform. Hetero is a prefix meaning different. Hetero means that it's non-uniform. So an example of a homogeneous mixture might be sweet tea. That's what they call it in the South. It's not sweetened tea, it's sweet tea. And if you ask for iced tea, they'll say, do you want sweet or unsweet? It's funny. You put sugar in tea, and the sugar dissolves, right? And it doesn't just settle out later, it stays mixed together. And the top of the tea is just as sweet as the bottom. It's uniform. You look at it and it's, clear brown tea and it just looks all the same. Heterogeneous mixture is not uniform. So something like macaroni and cheese would be a heterogeneous mixture. There's the cheese sauce and there's the noodles. And they're all mixed together, but you can see there's lumps where the noodles are, right? It's not the same throughout, so that's heterogeneous. So there's kind of the summary slide. The example they're giving here of a heterogeneous mixture is oil and water. You can shake them up, but they will not stay mixed together. This is tea with sugar in it. So we have some sugar molecules and some water molecules, among other things. This is a plate of sugar cubes. These are sucrose molecules, and all the particles in these sugar cubes are the same. And this is an element. I'm guessing that's like maybe copper. It doesn't look quite red enough for copper, but this is some metal. And in the metal, we just have individual atoms. This is an element, a compound, a homogeneous mixture, and a heterogeneous mixture. Any questions? So, example. Classify each type of matter as a pure substance or a mixture. If it's a pure substance, classify as an element or compound. If it's a mixture, classify as homogeneous or heterogeneous. So mercury in a thermometer. Is mercury a pure substance or a mixture? It's a pure substance. So we'll say PS. So for pure substance, we can choose between element or compound. It's an element. Now, how are you supposed to know that? Well, mercury is on the periodic table. If you see something on the periodic table, it's an element. Okay, so copper, oxygen, helium, nitrogen, sulfur, all those guys on the periodic table, they're elements. So mercury's on the periodic table, it's an element. How about exhaled air? Mixture or pure substance? Mixture. Now, is that going to be homogeneous or heterogeneous? It starts with an H. It should be homogeneous. Because when you breathe out air, does it have chunks in it? Not usually, right? Unless you're really sick, and then that's not really breathing out air, is it? It doesn't have chunks in it. It's going to have carbon dioxide in it. It's going to have nitrogen and argon and other gases that you inhaled in it, but it's going to be uniform throughout. That one's a little, the homogeneous, heterogeneous thing there is a little tricky. In general, gases form homogeneous mixtures. There are some exceptions, but generally gases form heterogeneous mixtures. They mix very well. How about minestrone soup? That's a mixture. So even if you don't know what minestrone is, soup, I think we all know what soup is. Soup is going to be a mixture. So minestrone soup is an Italian soup that's got like kidney beans and green beans and little chunks of sausage and noodles and things like that in it. So is that a homogeneous mixture or a heterogeneous mixture? Hetero. We can see individual parts, like chicken noodle soup or something like that. It's got chunks in it. It's heterogeneous. If we took the minestrone soup and we put it in a blender and pureed it, that doesn't sound very good, does it? But if we pureed it, we could make it homogeneous by grinding it all up and mixing it together. How about sugar? Sugar is a pure substance. Now, I don't expect that to be obvious to everyone at this point. There will be questions, something like this, on the exam. But I will try to make sure that it's more obvious to you than, I mean, if this was, see, this gets into different backgrounds of students. They always ask about diversity in the classroom, okay? So, you know, an Italian is definitely going to know what minestrone soup is. But what if we said egg drop soup or miso soup? Some people wouldn't know what that is, but those have chunks in them, right? Chicken noodle soup. So I will try to choose examples for the exam that everybody should recognize. And if on an exam there's something that you're like, I don't know what that is, please ask me, because I don't want to have lack of knowledge of American culture or some bias that I have from my Swedish Midwestern upbringing to mess up your score on an exam, because we're trying to focus on the chemistry, but sometimes other stuff gets in the way. Anyway, I don't know where that came from. Pure substance, sugar. Is it a compound or a mixture? It's a compound. Compound or element is what I'm supposed to be choosing between. It's a compound. Is sugar one of the elements on the periodic table? No. And it's not one of the 4 food groups either. as much as we might want it to be. Sugar is a compound. Yeah, I'll stop blithering now. So this is kind of a summary. Matter can be a pure substance or a mixture. A pure substance can be an element or a compound. Mixture can be homogeneous or heterogeneous. Mixtures can be composed of 2 or more elements, 2 or more compounds, or a combination of both. It could be 17 different elements, or it could be 1 element and 5 compounds. There's just endless possibilities for mixtures.